Hello everyone, welcome to the brand new episode of Video Geeks YouTube series. In this playlist, this is the second video of VRRP, and today we don't have any members of the Video Geeks, so I'll be only one to present the topic for this week. So let's start with the VRRP part 2. In the first part, we have seen all of the introductions, right? We have seen the universal cloud network topology. This is also known as leaf spine architecture. So the main lines that you can see, like which are the devices which are exposed to the internet, they are spines devices, and then there are leaves. Then we have seen this problem that, let's say, we have layer 2 leaf spine architecture where all of the devices connections are layer 2. There is no layer 3, there is just one entry point for our devices to access, and also that is known as gateway sometimes, or in general terms. So let's say we want to access the gateway, but there is no gateway redundancy that we have heard of till now in our protocols. So let's say we want to get connected to the internet. So basically that is different network from our campus. So we need some gateway who will pass our message to outside network. So if, let's say, one of the port is gateway, but one uh, gateway IP fails or interface, there are some hardware maladies. So due to some reasons we can get into some trouble. So for that purpose, we have seen the solutions. That, let's say, we make both of these devices to act as a gateway. But in that case, there are two questions: what is my gateway and where is my gateway? So what is my gateway? That is the IP address that we have mapped in the last video, and where is my gateway? That is MAC. So MAC is resolved by ARP, that we don't have to take care of, but the IP that we configure generally in this kind of properties, or you can say IPv4 properties, where, let's say, when we have configured the default gateway over here, but let's say we want to have two gateways, but then also, let's say, one of the gateway that we have configured over here in the settings, that might fail, and that in that situation, if, let's say, that that is failed, so we need to manually go through and we have to put the currently active IP of the gateway. So that is the trouble. So now what we have come across is to introduce gateway redundancy protocols. So now, in the last video, we have seen the FHRP. So there are three main FHRP protocols, and we have seen all of that. And these are all the introductions for the VRRP, not VARP, VRRP. Okay. So basically, VRRP, let's just start from here. So VRRP is like IEEE standardized gateway redundancy protocol. So it is standard protocol for gateway redundancy. Second thing is, like, it offers virtual IP based solution when one virtual IP is backed by multiple gateway IPs. So there is a concept of virtual IP. So this IP does not belongs to any physical interface or something like that, but this virtual IP that we will configure on the device setting that we have seen over here. And virtual IP is, since it is not connected to the physical interface, it will not get what you can say, it will not be shutdown mode, or it is not affected by the hardware maladies, and it is also not affected by some of the links get failed. So that way, and let's say there are multiple actual gateway IPs that are backed by this virtual IP. So the solution will be straightforward. Our devices will contact to this virtual IP, and then this virtual IP will send our packets to active gateway, whatever the active gateway IP is. And we don't have to worry about going in this configuration and changing default gateway IP whenever there is a failure, because that will be taken care by this VRRP. So that is the main VRRP thing. And the third thing that we need to know is it provides active standby gateway redundancy approach. So it uses the master backup structure. So what is meaning of active standby? That we have seen in the last video. That one of the, let's say, there are two devices that that we want to be act as a gateway, right? And there will be one virtual IP. But when we are using VRRP, one of that gateway IPs that will be only active, and one will be in standby mode. So we are providing gateway redundancy, but we are not providing any load balancing. So, and also that is known as master backup structure, because there is one master node and one is backup node. And whenever, let's say, master gets failed, the backup or the device which is in standby, the gateway IP which is in standby, that will be take place of the master, and that will be active afterwards. Now let's say there is this topology. So let us just to get familiar with the IP addresses. So let's say there is one host and the network is 10.1.1.0/24. So for the host, the IP is 10.1.1.100, and there are two gateway IPs, 10.1.1.1 and 10.1.1.2, that we have configured on these separate devices for on this topology. And there is one VRRP configuration that we have, which is 10.1.1.50, that is virtual IP. And let's say in the host, there will be IP settings. In the gateway IP, we have configured this virtual IP 10.1.1.50. And let's say we want to, whenever we want to connect to over the internet, we will contact this IP 10.1.1.50, which is virtual IP, and that will take care of, let's say, whoever is master, whoever is backup, that will be responsible to redirect our request to the internet. And this is the thing, that one of them will be master and others will be backup. So it ultimately introduced the redundancy, because let's say 10.1.1.1 gets failed, but we are contacting 10.1.1.50 and virtual IP. So VARP will take care that, oh, 10.1.1.1 that was master and that failed. Now we have to redirect our traffic from 10.1.1.2. So this will take place of the master. So after knowing that how VRRP works, there are few questions that you may ask, or right now we are not in direct interaction. So there are few questions that I have noted down, that is like you must know the answer of. So the first question is how master and backup will be selected. That is the protocol, the working of how VRRP uh, elects the master and backup. Second thing is what happens if the master fail. How will they know that master failed? And if master gets failed, how to set up new paths. So for this topology, there are four questions that you must answer, right? So now let's just move the solution, or you can say answers of these questions. So first question was how master and backup will be selected. So there are these three things that you need to be take care of while working with the VRRP. So first is priority mechanism. So it uses priority number. The more the number, or you can say the more the priority number, the more the priority. That is configured on the machines, right? But by default, there is some priority number like 100 that is configured on all the devices, or let's say it is the default configuration for the VRRP. So in that case, what will happen is all of the device will have same priority. So whom to select as a master. So in that case, that falls under the second category, which is configurable, or the second category is like not configurable. Let's just focus on the default. So as you can see, as I have told you, the default is 100, and let's say if all the devices have default priority, then the device with the least IP will become master, will be selected as master. And the last thing is configurable. Also, this priority is the number that you are seeing over here, that is the configurable, and you can change using the commands. So you don't need to worry about, you can make any device as a master by altering the priority value. And now let's just suppose first this is the first case, when both of the device have different priorities. So setup is same, the IPs are same, the virtual IP is also same. But let's say for this device, the priority is 100, and for this device, priority is 200. So in that case, this device will be master, this device will be backup. And now let's say with the default configuration, so both of the device will have priority 100. But with the default configuration, if both of the devices have same priority, what will happen is the out of all of the nodes, whichever node has the least IP, in this case it is 10111. So this device will be selected as master, and this device will be selected as backup. Now let's go for the second question, which was how will they know whether the master fails? So there is just one thing that you need to be aware about while answering this question, which is keep alive messages. So all the devices that are currently communicating in the VRRP, they will exchange keep alive every 1 second. So let's say master will send keep alive messages to all the participating backup devices at every 1 second of interval. So there are these two things, hello time or hello message or keep alive messages that are being sent on every 1 second of interval, and then there is a dead timer. So let's say for this backup device, let's say those device gets failed, the master gets failed, and if let's say backup device doesn't receive the hello time, hello packet or keep alive messages for 3 seconds. So in that case, the backup will come to know that the master is failed. So that's how they will communicate and they will know that master has failed. So this is the answer for this question. So let's say the third question is if master gets failed, how to change the path. So as you might know that let's say this device is master, so the IP configuration is the same as we are following since the beginning of this example. So let's say this device is master and this device is backup. So in that case, whenever we configure VRRP, there will be virtual MAC, because obviously with the IP, for knowing the actual path, you need MAC addresses. So for that, let's say this device is master. So at that time, whenever this host will query for the gateway IP's MAC address, when let's say when we want to get uh, onto the internet, or we want to communicate over the internet. So at that time when this device query for the MAC address of the gateway IP, which is in this case virtual IP that we have configured on the host, so that will exchange the MAC, and the MAC will point to this path because master is connected on this link, as you can see. But in the scenario of master get failed, it needs to know that that the packet, they don't need to now send on this device, this link. They now need to send on this link. So in order for this device to know that, they need to have what you can say MAC address of this from this physical link. And how will they know that? So the answer is GARP or GARP, or that is also known as Gratitude ARP or Gratitude Address Resolution Protocol. So whenever this device backup will know that this device master has failed uh, because of the dead timer has expired. So in that case, what will happen is this device itself will send the ARP, or because this ARP is like not requested by the host, because it is directly sent by these backup devices. In order for this device to know that now if you want to connect to this 10.1150, you need to take this path. So that's why this is called as gratitude ARP. And now uh, as it receives the ARP, it will know that I need to use this link. So that's how this VRRP works, and that is very interesting behavior of this VRRP. And now feature is, there is one feature that you need to know. So we have achieved the redundancy as we all wanted to be at the first place, that we want to introduce redundancy at the gateway level. So that we have achieved. So what about the load sharing and traffic? So the problem is, uh, all the time the backup will be idle and it will not do anything. But let's say our traffic is so much so that the link utilization will be very high. So in those cases, if somehow there will be a mechanism to, let's say, divide our traffic, so that would be very good, because we can distribute 50-50 traffic on both of the devices, or we can have multiple IPs configured on multiple interfaces, like that would be good. So we can do that actually. That is one of the feature of the VRRP. That is a feature which is allowing you to configure master node per VLAN basis. So let's say you have 15 VLANs in your layer 2 leaf spine architecture. So you can do a load sharing, because you can configure a master per VLAN. So a node can be master in one VLAN and it can be a backup in another, because you can alter with the priority number. Remember? So that is one of the feature. So now let's do the practical, and I'll quickly demonstrate you how VRRP works. So now you might be knowing about this topology that we have took in the video of previous sessions. So you do not think about, or you do not notice this P4 channels or MLAG that I have written over here. Just to show the topology, just to give an overview of the topology that I have. So I will be using tower core 1, tower core 2, and route field vector. So there are these three ports, 4 slash 26, 27, 4 slash 30, and 24 and 25. So you just keep in mind these ports. So what we'll configure VRRP on tower core 1 and tower core 2. So let's just do that first of all. So to do that, what we can do is, first let's just create some VLAN. For that, we'll query first of all that. For that, first of all, we'll query that what and all are the VLANs that we have configured. There is just a default VLAN. So what we'll do, we'll quickly create one VLAN, let's say 10, and now we just exit, and over here also VLAN 10, exit, right? And now we'll create SVS, right? So we have configured SVS on both of these devices. Now what we need to do, we need to just enable VRRP. And for that, we just need to type VRRP. So for configuring the VRRP, we need to go under the VLAN interface VLAN configuration, and after that we can type VRRP followed by the interface number, followed by the uh, what you can say VRRP uh, we want to enable for the protocol IPv4. Then the IP address, virtual IP address that you want to be, or we want for the VRRP, and then we can just hit enter. And now we can type exit, and for the tower core 2 we can go for the interface VLAN 10. Now we can type the same VRRP 10, and then IPv4 followed by the virtual IP, right? And now what we can do is, we can just type show VRRP. Okay, show VRRP. Okay, for us to see the VRRP, we need to have some VLAN, some ports to be configured in VLAN 10. So remember, we have 4/26 and 27. So we can just go for this, any of them. And we can make this port to be part of VLAN 10. Now as you can see, we can see that this node is a master. And for this node also, tower core 2, and now if you will see, see tower core 1 is master and tower core 2 is backup. And now we can see default priority is 100 over here also, over here also. And if you will see, this is 10.1.1.1 least IP, as this is 10.1.1 local IP is for tower core 2. So you can see for the VLAN 2 over here is 10.1.1.2, and as this was not the lower IP, so this is selected as backup, and tower core 1 that was having 10.1.1.1, that's why it has been configured as a master, because both of the device has 100 priority number. So that is how VRRP works. And let's say you have some ports over here on the route reflector. Let's say we create one VLAN. After that, we create one interface SVI, and we give it the IP 10.1.1.100, and now we put, let's say, the port number 24, right, to be part of, let's say, VLAN 10. Sorry for that. And now let's say we try to ping 10.1.1.1. Okay, it's not working. Just a second. Okay, we have 24 and 20, what you can say, 24 to be part of the VLAN 10, but we don't have flow/30 to be part of VLAN 10. So it will not accept the traffic. So on tower core 1, right, we can configure VLAN 10 over here, and after that, if we can see, we can ping 10.1.1.1, we can ping the virtual IP, right, and we can ping the other backup device also, right. And now let's just experiment with the one thing. Let's say somehow there is no VLAN 10. So in order to simulate that, we go under this port and we'll manually shut this port. And let's just see. So yeah, as you can see, this port is NPN down. And if we just try show VARP, so you will not see any output, but on tower switch tower core 2, previously it was backup. Now if we try show VRRP, you can see this is master. And now let's say if we try to ping virtual IP, you will see it is getting replies. So that's how VRRP work. First, we have configured VRRP on both of these devices. So Tower Core 1 was the master, Tower Core 2 was backup, and we were able to ping virtual IP. And now let's say there was some hardware anomalies, and due to that VLAN 10 SVI, or we can say the actual port, the master device goes down. So now Tower Core 2 has been elected as a master, and now if you try to ping the virtual IP, we are still getting replies. So this device, Raft Reflector, it has no idea that 10.1150 is the virtual IP. It has been backed by 10.111, and 10.111 was failed, or you can say there were some errors. So that's how VRRP works, and hopefully you've got the idea about VRRP and all the stuff, all the things, theory part, and including the practical, the very basic practical, or you can say demo of the VRRP configuration. Hopefully you've got some knowledge, got some things working around in your mind. For this video, that's it. We'll meet in the next video. Till then, keep learning and keep exploring.